All right, so we already did the bell work. It should all be review. Should. Let's find out how well you guys did with it. So this first one, when you went through it, who feels confident in walking us through what you had to do? Anybody?
Just replacing the two for the
Exactly. We're basically, if you think of this as just being like f of 2, that's all we're doing. So this is 3 times 2 squared plus 2 times 2 minus 9, which is going to be what? 4, 12, 16. So 7? Somebody said 5? It's definitely 7, guys. All right, this one, same thing. I'm just plugging in pi over 2. So that means that what I'm really doing is finding cosine of 3 pi over 2. Who knows the unit circle well enough to know? 0, exactly. If you didn't know it, it's on the wall, right? It's back there. It's also up here, okay? The last one here, what happens when I plug in x equals 3 this time?
6 over 0.
6 over 0, what does that mean?
Undefined.
Undefined, right? I cannot divide by 0. I don't think you guys learned this, but the reason is that there's an infinite number of answers when you divide by 0, so we can't do it. Okay? That's what undefined means. There's too many answers. All right, that means that now we can start the lesson for real. Are you ready for some Greek? Did you guys know you're in a Greek class? Look at all this Greek. Anybody able to read that? No? I don't even remember what this one is.
Where is this?
I think that's epsilon, yeah, but it's not like epsilon the way we would think of it, because usually we write it as lowercase e. And then this is sigma. I'm not going to worry about that. Don't worry about it if you don't understand this part. Guys, this is the part that we're going to care about, and I'm going to focus on that right now, okay? So, the way that I read that is the limit as x approaches c of f of x equals the limit, whatever that value is, okay? So that's what's going to be important here. So if we go down here and look at the verbal definition, okay? L is the limit of f of x as x approaches c if and only if L is the only number you can keep f of x arbitrarily close to just by keeping x close enough to c, but not exactly equal to c. That's a mouthful, right? That sucks. So instead of that, I think this is actually the same lesson that you guys did. I don't think this one I changed at all because this one's so easy. It is? It's exactly the same? I thought so. This one is the same. The first lesson is the same, and then we get more intricate. So then you guys will have to actually do some work. So then that means that you guys, the three of you, might actually know. What does this say then? How did I just say it? There's two different ways. Do you remember? Do you have it written down from last time?
It's the limit of f of x
Good.
as x approaches c.
Is L, right? So basically what that actually means, you guys, is that the y value that both sides approach, okay? Now we could technically say this differently. We could say this as the limit as x approaches, as x approaches x, that should be x approaching c, sorry about that. As x approaches c of f of x is L. I prefer the first way, but they're both correct, right? It doesn't matter which way you read that, okay? So I'll give you a minute to write those down. And then we're going to do some practice. Pablo, are you done, or are you just like reading it intricately, making sure you understand?
Yes.
Yes, the second one? Got it. Anybody have any questions about that? Or does that make sense? It's just learning how to read the math. That's all this lesson is mostly about, okay? So let's jump down then, and let's try and approach this graphically. Now, we're not going to do this graphically very often, but it's the most helpful way for us to first learn it, okay? So, if we've got a couple of graphs here, they're almost always going to be piecewise. Okay, they're going to be like you guys know what piecewise are? Yes? Okay, good. Basically, it just means we've got a bunch of different equations. So if I look down here at this first one, this is the limit as x approaches -1 of f of x. So what we're going to do is we're going to go up here to f of x, and I'm going to approach negative 1. Now, what I need to do is approach negative 1 from both sides. Do I approach the same number? So, I'm going to go over to the board here. If you do it this way, put your fingers on it, a little bit to the left and right of negative 1, and follow it to there. Do your fingers touch? Therefore, it's not approaching the same thing, right? From this left side, we approach negative 1. From the right side, we approach 2. If the two sides are not equal, it means that it doesn't exist. So our answer down here is going to be that it does not exist. And our reasoning is going to be the left side doesn't equal the right side, okay? That's the justification we're going to use for pretty much all of these. Like, it exists because the left side equals the right side, or it doesn't exist because the left side doesn't equal the right side. Let's actually jump down and do 3 next, because 3 is dealing with the same kind of limit. So this is the exact same thing except for g, right? The limit as x approaches negative 1 of g of x. So let's go look at g of x. We approach it from the left and right. Now this is where everything changes, okay? This is not like math you did previously. The answer is not 2, right? Do you guys see how the actual function of g of x is 2 at negative 1? Right? Like, our function exists up here. But the limit is what we're approaching, and we're approaching 1. Does that make sense? No? All right. Basically what it means is, in the past, we wanted to know what is the actual function equal to, which would have been right here, right? Now what we're saying is, forget that, it doesn't matter. What matters is, what are we approaching? So we kind of trace towards that point, and we say, it's trending towards 1. Okay? So if we think of even using that word trending, it kind of helps us understand that what we're getting at is not necessarily what the value is, but how we would make predictions. So we would make the prediction that it should be 1. If it happens to be 2, well, that means something weird happened, and maybe we should investigate that. Okay? All right, so now let's look at the other side here. Let's go back over to 2. Okay? So now we're going back over to f of x. We're going to say the limit as x approaches 1 of f of x. What do you think that little plus sign means there?
From the right side.
Exactly. So positive here just means from the right side. So it's a one-sided limit. Now, whenever we have a one-sided limit, it pretty much always exists. Okay? As long as the graph exists or the function exists, the one-sided limit will always exist. So as I go to 1, I go to the right side of 1, and I trace it down, and I approach what? What y value am I getting close to there? 0. So this is just equal to 0. Okay? Try the g of x one. It's not one-sided, actually. You can still do it. Try g of x on your own. See if you guys can figure it out. I'll write down the answer, and then you can look up and see if you got it. How many of you got it? Anybody else get it? A couple of you? More of you? Good. So this one's kind of interesting too, because in this case, this is sort of where we learn what we should first do with limits. You just check the actual point. So here, there's nothing weird going on, right? The function just exists there. If the function exists and it's continuous, then that's just what the limit is, right? There's no trick to this. It's like, as I approach from the left and right, I'm approaching -1 because that's what the function is, okay? So when we get to the algebraic approaches later, you'll see how that's the first thing we do. We just plug it in and see if the number works. Okay. Scroll down a little bit here. Let's look at this. What do you think is happening here? So we're going to take them like kind of separately and then just add them together. That's all. So we're going to take the limit as x approaches -1 from the left of f of x and then of g of x separately and then add them together. So we know they're going to exist because it's from the left, right? It's a one-sided limit. So if we look at f of x, from the left, that's this side, sorry, we approached what from this side? 1. So that's going to be 1, and we're going to add whatever we get for g of x. For g of x, as we approach -1, what do we get from the left?
1.
We approach 1 as well. So all this one means is that it's going to be quite literally 1 + 1 or 2.
So can you repeat that for me?
The whole part? The whole thing? Okay. So what this means here is that I'm going to just take the two limits separately and add them together. That's all I'm doing. So I'm going to go and look for this one. And as I approach f of x, or on f of x, as I approach -1, from the left-hand side, I get the value 1. That's what I'm getting closer to. Okay? For g of x, I'm going to do the same thing. And as I get closer and closer to -1, I just get closer to 1. Right? In this case, I'm actually staying at 1. Okay? So then what I do down here is I say, well, the limit of f of x as x approaches -1 from the left is 1. The limit of f of x, or g of x as x approaches -1 from the left is 1. And then I add them together to get 2. So this next one's going to be very similar. Okay? We're going to subtract them, but what do you think the 2 and 3 mean? You're just going to multiply them first. That's all. Just some basic arithmetic, okay? So this is going to be 2 times whatever the f of x limit is, minus 3 times whatever our g of x limit is. So let's go look at the two limits as they approach 0. On f of x, as I approach 0, what number am I getting close to? 2. And as I approach 0 on g of x, what do I get close to? 0. So for f of x, we got closer to 2. For g of x, we got closer to 0. Anything times 0 is just 0, so that's going to go away. And our answer would just be 4. Okay, because it's 2 times the 2. That makes sense to everybody? We all good? Yeah? All right, let's go look at 7. So in this case, what do you think I'm going to do here?
Multiply.
Just going to find the two limits and multiply them. That's it. Okay? So I'm going to find the limit of f of x as it approaches -1 from the right, and then g of x as it approaches -1 from the right. So let's go do those two. As I approach -1 from the right, what do I get this time? Not 1, but 2. And then as I approach -1 from here, what do I get on g of x? I get 1 on this one, right? I got 2 on f of x and 1 on g of x. So this was 2, this was 1, and so our answer is just 2 again. Do you guys want to try the next one on your own? Try number 8 on your own. Okay? Try it on your own and then I'll tell you. Well, then just wait. Give everyone else a chance.
Well, I already did until 10. I still more or less.
Remember. That's good. Once you guys got it, look up, see if you got it right.
This outline is also because you're dividing by 0.
Kind of. Yeah, that one is like a little bit different, so I'll talk about that one. Ultimately, you're correct. Ultimately, you're correct. Everybody get number 8?
I don't remember how to do this thing.
All right, I'll tell you in a second. Okay? Guys, can I do 9? 8? 8 does not exist. Did anybody need help with that one? Why does it not exist? Let's go look at it. So for f of x, as I approach 2, I'm getting 2 different values, right? I'm getting 1 and -1. If I get 2 different values, that means it doesn't exist. There is no limit. Okay? So when I look at g of x, even though this one does exist, it doesn't matter because I'm getting does not exist times a number. The does not exist takes over. Okay? So for this particular one here, right, because the limit of f of x, this does not exist, it automatically means the whole thing doesn't exist. Make sense? All right, let's look at 9, because 9 is a little bit different. Here they do exist. So we're approaching 0, which I think we already did, didn't we? Yeah. When we approached f of x, as x approached 0, what did we get? No, it's 2. We'll get there. You're right, but let's get there. And then what was g of x as we approach 0? 0. So both of them exist. The issue is that I can't divide by 0, so this is indeed undefined still, but it's the entire thing that's undefined. Each individual limit exists. Does that make sense? So it's like slight difference. Okay? All right, so for the last one, I'm going to rewrite this a little bit. Because this is a little bit different than what you might expect. What this really means is g of the limit as x approaches 2 from the right of f of x. There we go. I'll splice the two videos together later for them. So guys, now what the difference here is that I'm not taking the limit of both. I'm taking the limit of f of x, the inner function, and then I'm just finding g of that value. Okay? So if I look at f of x, I want the limit as x approaches 2 from the right. From the right here, it's approaching -1. So that means that this is going to be g of -1. Now I'm looking for the specific value, not the limit. So now when I go up here, at -1, the value is 2. Because I'm no longer finding the limit, right? Now here I'm just finding what is g of -1, and it is 2. So this is where we go back to thinking like we did in pre-calc, right? If I'm looking here, the value of the function is 2. The limit is 1, the value is 2. Okay? No, it's, yeah, exactly, because this is filled in. So this means there's a hole, right? And this is, like it's a point in discontinuity, right? And I think that's it. That's really annoying that I had to make 2 videos for that. All right, but I'll stop that one.